Hey, how's it going? I'm going to talk some more about digits, patterns, shapes, and beyond. The title of this video is 12,960 plus Sri Yantra. That means like add them together, because you'll see. This right here currently does not appear to be a Mayan calendar, but I assure you it is. It has everything to do with the Mayan calendar. I'll explain in just a moment. The number 12,960, when doubled, is 25,920, which is the resolute value to a Mayan calendar. And this obviously is a Sri Yantra, and this comes from South America, this comes from India. I'm just going to take a moment to explain a little bit about how the formula came to me. I spent a long time looking at two-dimensional, three-dimensional, and beyond. My observations of such just kept leading me to more open territory. Eventually this came back into my life, and I spent a really long time trying to figure out why I couldn't draw it. And to make it even worse, I found that there's several versions of it. There's not just one way of drawing a Sri Yantra. It became extremely confusing. And then this point in my life happened where the number 108 just wouldn't leave my head. And that night, after about 14 hours of going insane because of this number just constantly ringing in my head, I decided I'm going to just chill for a minute. Try and get everything out of my head. I need to go to bed soon. And in the process of laying there on the sofa trying to clear my mind, all of a sudden I just thought, why don't I put the 108 and the 72 next to each other with the dot in the middle, and then double each number and half each number? From there, things just went completely nuts. Like really, I then spent the next 6 or 7 hours just sitting there on the floor with paperwork around me. A little while later, this came into existence. This was my first major kind of breakthrough in that sense. Most of it happened that evening, on this paper anyway. A little bit messy, which is why I showed you the tidier version in the previous video. And then shortly after that, I realized that you can put the 90 in the center of it. Then it came to my attention that you only need these 3 columns and these 13 rows, which is when I started to branch out and realized this is what it looks like with the 90 in the center, just doing 5 by 5. This is with the 90 in the center, but this is horizontal and this is vertical, and your numbers, they change. This is a decagon. This is a 10-sided two-dimensional pattern, and you can run the numbers, but in reality there's kind of no point because it's the pentagon. It's the exact same numbers that are going to show up, and just in different way. And then there's the octagon, which I'll more than likely discuss in another video. There's plenty of ways that you can look at the information that's being presented, and it doesn't matter what perspective you like to apply, it's going to lead you to the same place, and I'm going to show you what that same place is. After spending a lot of time with the formula and coming to the realization this 6-12-8, which I'm about to explain now, was extremely relevant. That's what showed me how to create the grid, the 4x4, which can be turned into a 12x12, or an 8x8 if you want, or 16x16. There's lots of different things that you can do with it. It depends on how you choose to use the information as well. I found that tetrahedron, I found the pentagonal form that was there, which was different. It propelled me because I knew that there was much more information to uncover. So I'm going to explain 6-12-8 now. In doing that, I should probably put this here. Quickly have a look at the Mayan calendar. We'll remove this section here, okay, because they stylized this area. There's a reason for that, because they're showing you 9 points. Okay, this would be the 10th point. You're actually looking at something that has reference to a dodecagon, which is a 12-sided two-dimensional shape, a pattern, whatever. You're not using 90 and 270 in this, for good reason as well. They don't use it in the Sri Yantra either. The point is, when I observed the Mayan calendar, it confirmed for me immediately upon looking at it. I mean, I haven't looked at this thing in over 20 years, or about 20 years. So I didn't really remember a lot from it, but you know, the number 25,920 and 12,960 are extremely relevant. So it became obvious I needed to look at the Mayan calendar. The moment I did, it confirmed 612.8. So I'm going to explain 612.8. The radius of a circle will always be the same length as any 2 points of that circle, which are 60 degrees apart. If that was not the case, then the flower of life, it just wouldn't work. It's not possible for the flower of life to exist in the way that it does if the radius and the distance between 2 points that are 60 degrees apart is not the same. Okay? It just doesn't work. So once you found those 6 points, how do you choose to observe the information? Me personally, what I think, I mean, it took me a little while to kind of work a few things out. I was using the flower of life itself, and I was using the Vesica Pisces, and it just kept getting more and more complicated. And then I realized you only need the one circle, and that one circle is going to show you the one square. How do we find that square? That's key. We need to find that square. So what we do is we take our 6 points and we draw 2 large triangles. Where those 2 triangles continuously cross over and meet each other, you can now draw 3 straight lines that go through them, like so. In doing so, if you want, you can turn that whole thing by 30 degrees now. You can remove the information that you have, because you have the 12 points. You can turn that information by 30 degrees. And if you know what you're looking for, you'll find that there's multiple cubes that exist within this. I mean, you've got that blatant cube that sits right there in the center. But what's happening is you're looking at the 3-dimensional properties that are breaking this, what appears to be a 6-pointed star, into 8 different sections. So you're looking at the ability to take something that is of any dimensional property, put it into one of these cubes, and then cast it into greater dimensional properties. If you really want, you can take all 12 points and create some beautiful, eloquent 12-pointed stars, kind of like a spirograph in some ways. But what we really need is that square that I was on about. Now, if you look closely, you can find 3 squares inside of this that's currently available. But we only need the one, just that one square, that's it. Once we've got this one square, it's a matter of recognizing to extend the information beyond the circle. You need 3 horizontal lines and 3 vertical lines. You then apply the diagonals, which is 3 diagonals in one direction, 3 diagonals in the other direction. The points that you need are already available because of the connection points that are there for the squares. When you've drawn those lines and you extend them beyond the circle, you can see the connection points that come into existence. And then it's just a matter of drawing your external lines to create the square. You've now got a 4x4 grid. That 4x4 grid can be broken into a 12x12, which is where your 13 comes into play. Or if you want to look at it a different way, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Those key points that you need. Once you've found this, it's going to make a lot of sense as to how you can find pretty much any angle you want. We started with 60 degrees. We turned it into 30 degrees. Now we found 45 degrees. That's why it's 6-12-8. That's why the system works the way it does. So, quick explanation about the Mayan calendar. There's a circle that appears in the center, which has a monkey god face in it, and he's sticking his tongue out. Go and run this, and draw all of the relevant lines that you need from the 1 to 3. Okay, so you need 3 blocks in one direction and 1 block in the other direction, and then you have to cross it diagonally, like so. And then you keep doing that, and you keep doing that, and you're going to end up with a really weird pattern that happens in the background that's going to show you lots of interesting information. When you take the monkey god face away, it becomes more apparent that this point here and this point here, they connect. They connect like that. So you get this really interesting pattern that weaves in and out of itself. You know, if you wanted to get technical, you could go back to something like VBM, which is a modern, you know, it's easy to use VBM. It's a modern version of the kind of mathematics that they were looking at. And it shows that it connects right there. Because you've got your 936, and it's happening on an inverted level, but then you've got your 1, 2, 4, 8, 7, 5 back to the 1, and then you get the inverted version of that as well, which happens in the system. It's really clever how that works. Since the number 12,960 is not the resolute value to the Mayan calendar, I think it's fair to say it's probably best to double it. Which is what I did. I just literally turned it by 90 degrees. That's when these 4 points become extremely relevant, because they're the only 4 points that get reused. Clever that. Now, admittedly, it got to a point where I had to realize I can't focus on both of them at the same time. So I had to change my focus in some ways to just one. Which is about the time I realized that the formula itself literally explains how the Sri Yantra is made. How easy was that to miss? I'd gone so deep in the formula that I'd forgotten how it came to me. And it was a key component, this right here, the Sri Yantra. Immediately upon realizing this, it became obvious that what I needed to do was put down 2 pentagons for the simple reason the 72 and 108 are both used. One's in the normal upright pentagon, one's in the inverted pentagon. 108 obviously being a key number. The formula is expressing pentagonal form continuously, so that's kind of obvious. There's 10 of the points that we want of the 14 points that exist external of the Sri Yantra. What about the other 4 points? Well, this is where it gets clever. If you look at this point here, obviously it doesn't touch the circle. That comes into existence because of the number 36 and the number 324. The number 72, this is the next number along that would have been from the 10 major points of the 2 pentagons. The only number that exists directly in the center of those two, which happens to be a root value of 9, is 54, which is half of 108. So I think it's fair to say you just go 54 that way, then 54 that way, then 54 that way. That's when you get the 54, the 126, the 234, and the 306 come into it. That shows you the 14 points of the Sri Yantra that are external. So here's the numbers for that. 36, 54, 72, 108, 126, 144, 180, 216, 234, 252, 288, 306, 324, and 360. Okay? But what about these points here? Well, it becomes obvious. If we're working with something that's got 9 triangles, and I've just said that the whole thing is based on the properties of the number 9, it's all a root value of the number 9, then we need to find something that is to the value of the number 9. 81, 99, 261, 279. That's what you need. The 81, the 99, the 261, and the 279. And that's how these 4 points come into existence, right here. There's a lot more that can be said about this. But for now, I'm going to talk about the intrinsic value that is these 6 points. Because they're the only 6 points that touch the circle. The other points, they don't touch the circle at all, do they? When you take those 6 points and you look at the numerical value that exists on the circle itself, which is 72, 108, 180, 252, 288, and 360, then you add them together, you get 1,260, which is a nonagon, which is a 9-sided 2-dimensional pattern. How convenient. That is rather convenient, isn't it? I think it's fair to say that that's not the only version that I've done of the Sri Yantra. This one here, you can see that the points do not touch the lines, whereas in this one here, the points do touch the lines. This one here really is based on the properties of the number 9. You need to find every 9 degrees to make this work. Every 9 degrees. Then you have to consider 4.5 becomes relevant. Seems like I've found a mathematical formula that, at the very least, explains to me how to draw the Sri Yantra. Let's talk about a few things. Talk about a few things in relation to this here pattern called the Sri Yantra. It's common in India to observe these stars. I'll just show you that one there. Okay, so we have a 14, a 10, a 10, and an 8. That's 4 different stars. There's also this information, which maybe I'll talk about that in another video. So what are those then? That's a bit weird. Well, let's have a quick look at a few other things. There's blatant rhombus that's involved in this, isn't there? I think that's obvious. There's blatant rhombus there. But there's also this weird thing as well that shows up, which is actually a square. And then there's this pentagon. And there's the hexagon that sits right in the center. And I think by now you've figured out what I can do with the hexagon. Then there's this thing that looks a bit weird. I can't, like, I don't know. Can I figure what that is? I don't know. It's a bit weird, isn't it? Actually, it's a cube. It's just a different stylized cube to this one here. I haven't put all of the information in because I didn't want it to get more confusing than it already was. Obviously, in this one, there's only 2 lines that are needed. Interesting how that works. So, if we've got the 8-pointed star, which we've already observed previously, it's an 8-pointed star, isn't it? Because we spoke about that when we spoke about the cube, which is, well, it's a shame this wasn't bigger, because then it would look more like, this line was smaller, but it's not, because it's not bigger. So why doesn't that fit properly? It's based on the depth perspective, the distance that you are from each component, the size of each component, okay? So we've done the 8-pointed star. We've done a bit of weirdness there with some other shapes that show up, patterns that show up, whatever. What about this, because this is a 10-pointed star, isn't it? And then this is a 10-pointed star, and that's a 14-pointed star. So what's going on there? Well, this here is a 20-pointed star, and it's made of 20 tetrahedron. It's all it is. It's 20 tetrahedron cleverly put together to create a 20-pointed star. But the beautiful thing about this is it's dodecahedral and icosahedral at the same time, which is why there's these 5 green points here because that's one face of a dodecahedron. But the icosahedral, that's all the red. That's all the red that's in there. That's the icosahedron. 10-pointed star. Okay? We'll take this edge here where my hand is, what I'm holding it onto, and then the one that's closest to you now, this one here, and we'll look through the exact center of that edge, through the exact center of the object, to the opposing edge that I'm holding. And if you look externally, you'll find there are 10 points. 2 points here, 2 points here, 2 points here, 2 there, and 2 there. Okay? That's 10 points. If you take it and you look at it through this hole that exists here, I'll hold the blue one today. The blue one. I could do the yellow. Doesn't really matter. But I think this one's more obvious. That's why I did it in the colors that I did, to make it more obvious. That's a 10-pointed star, isn't it? Wow. All we need to do now is find that 14. This is the harder one. You take this edge here, and the edge that I'm now holding in the background there, as you can see as I'm waving it around, and you line them up. It gets a little more complicated because a lot of the information has a tendency to disappear. But one of the things you need to be aware of is what happens over on these sides. Like, for example, this section here. You see how there's this X that wants to form, and then you can make the same thing happen over on the other side. It's not so easy to give you this view with the camera, because in my opinion, you do genuinely need both eyes. The camera lens has a tendency to compress the information into what would appear to be a two-dimensional form anyway, which is why some of the other stuff's been easy to explain. If you observe this little tiny point right here, and then this point right here, this goes back to something I was saying in the previous video, the Platonic movement, about how you have to recognize that just because one part of it appears to be smaller, we're actually looking at components that are exactly the same size. So when you turn it into two-dimensional form, it becomes the Sri Yantra. That's beautiful, isn't it? But that's not all we're looking at. I mean, I did say in the Platonic movement as well that in the dodecahedron, on the face linears, you can find 5 cubes, didn't I? Well, if the 20-pointed star is dodecahedral and icosahedral at the same time, then we're observing pentagonal form continuously in lots of different ways, right? And that means there's going to be cubes that are present there, which might help to explain that little tiny cube that we found with the 8-pointed star, depending on the way you choose to observe it. You know what? I'm going to go on a little bit of a digression right now. You see, I found this as well. Now normally, this line here, and this line here are not usually presented in the information. Like in this one here, you can see that there's a 6-pointed star with a dot in the center of it. Okay? But in this case, the information has been expanded sideways. So let's have a look at this here. There are 60 triangles that exist, 60 triangles that exist out there, external to that 6-pointed star. To create one 6-pointed star and 60 triangles using this system, it takes 54 dots. Dot number 55 is not being used, is it? It's just sitting there in the center. On the basis you choose to use dot number 55, and you cross this information straight through the center there, straight through the center there like that, straight through the center there like that, and then you create the hexagon that's going to give you 12 extra triangles. You're going to end up with a total of 72 triangles. Which is interesting because 54 is half of 108, and 72 is the external angle of the perfect pentagon. Clever, that. So is that. I think that's really, really cool. I love the fact that these squares, they appear right here, and there's 3 of them that just sit there, not just that little tiny one. There's loads of little squares like that. And that's what happens when you expand the information sideways. In reality, what we're looking at is a giant cube, and in that cube there's lots and lots of information. In fact, if you look closely, there's information that exists on the edges of this, or on the sides of this. It's just not, I'll explain it in just a sec, actually. So we have this pentagon and an inverted pentagon, which easily could be a reference to dodecahedron. There's this right here, which is the top of an icosahedron. Then we have this hexahedron, this hexahedron, and this hexahedron. This tiny little one here multiplied by 8 equals this. This tiny one here multiplied by 27 equals this, which, you know, some of it's being hidden by that 6-pointed star that I thought I'd leave in the center there to make it a little more obvious that we're looking at the same information. You want an octahedron? Well, yeah, there's one right there. Tetrahedron, that's right there too. It is a giant cube, though, is what it comes down to. So here's the cube, and then as you can see, there's these dots, and I've put some extra lines that go around the edges there, because that's the extra information that's just hanging around for good reason. When you start using all the information to your advantage, you see that there's these triangles where you can just draw lots of different straight lines through. In fact, if you just look at this one here, for example, this one triangle has 3 lines that go through it. Those 3 lines are showing us 3-dimensional space. Every single triangle is showing us 3-dimensional space. Hence the reason why you can find this 4x4 grid that can now be broken down using these connection points that come into existence to show us the 12x12 grid. Clever that, isn't it? So this is one cube that can be found. This is a cube made of 27 blocks. And these are little tiny versions of the other information that can be found. And as you can see, we're looking at a cube from the perfect perspective. And in this case, not all of the information has been applied, just to give you a fair idea as to the fact that we're looking at a cube that has more than one cube involved. And yeah, I don't know why I put that in there. My apologies. That's probably not... since I'm here, you can look at it like this, because that's how the formula is going to show you when you create your block grid for the I should have put that with the 6, 12, 8. My bad. Anyway. Wow. Now we get to talk about this beauty. This is one of my current favorite patterns. I have phases, and I'm going through a phase where I really love this pattern. It's beautiful. The amount of simplicity that is involved in this pattern is phenomenal, and the amount of complexity that is involved in it makes me want to know more. That's just amazing, isn't it? So just a second ago, we looked at some cubes, one of which is based on the hexagon that I'm now showing you, that's done in pencil line, that's sitting with a flat bottom and a flat top. The other of which, I'll show you a small one. Here's a little small one, like so. Showed you that already in the other paperwork. Yeah. If you want, you can find. We'll start it from here. We'll go 2, 2, 2, 2, 2, and 2. You see? So it's the hexagon that has the flat sides, not the flat bottom and the flat top. When you put that information together, you're literally looking at dimensional properties. Now, something else I'd like to mention, as you can see, I tried to do the decagon there, and then I realized that it's kind of pointless. I'd like to mention these numbers here. This is the nonagon. Now, as you can see with the nonagon, it starts with 140 and 40. And the number 5 becomes extremely relevant. Extremely relevant. Go and run it and you'll have some fun. There is something else that I feel that needs to be explained, though. I wouldn't want South America to think that I haven't done anything. I mean, there's a few things that I have done that I'll discuss at a later date. The number 260. If you look at the Mayan calendar, you'll find that there are 4 sections that have 10 units that are diagonal lines that point to a dot, which is a representation of the number 5. 10 times the 40 times the 5 gives us the 200. If you look at the fact that the top and bottom, the left and right, they're hiding where 12 potential units could go, that gives us 52, doesn't it? Which could be a reference to the 52 weeks of the year. The 52 multiplied by the 5 gives us 260. If you take a circle and you put 260 at the top of it, and you consider that this is going to be broken down into 260 portions, then you do the points that are the 8 major points you need to find the octagon, or 90 and 45 degree angles, and you take the numerical values that appear. It breaks down really, really simple. 1, 2, 3, 4, 5, 6, 7, 8. How convenient is that? That's like a coincidence, is it? Yeah, that's a good word. There's many ways that you can look at the information that is outside of a circle. We know that we can observe it as 0. We know that we can observe it as 360. If you wanted to observe it as 1080, that's fine. You can do that. Why would you do that, though? Well, you're looking at 3 spheres. You're looking at a sphere, which is 3 circles, isn't it? So you just draw a straight line there and a straight line there, and then your dot in the center of it would be the perfect connection point, so that straight line is actually a circle being observed from the perfect perspective, so that they just look like straight lines. If you observe this as 108, it really breaks down into simplicity. You're looking at 3, 6, 9, 12, 15, 18. See what I mean? It gets to the 27, then it gets to the 54. There's a lot of different ways that you can observe the information that happens on the external of a circle. If you wanted to apply letters, that's fine. You can go ahead and do that. But there's something missing. There's something's not right. There's information that I haven't discussed that is extremely relevant in relation to what both of these we're looking at. I mentioned the number 9 has massive relevance to both these versions of the Sri Yantra. Okay? Massive relevance. I cannot emphasize that enough. This uses the properties of the number 9 to the point where you need the 40 units of 9 that can be found in a circle. This, it's not as technical. This one is definitely more technical. Okay, that's for sure. Didn't I say that you can take 90 and put it in the center of the formula? I did, didn't I? 90 is a key component, really is. Especially when you consider that this point right here, this point right here, this point and this point, they're 90 degree angles. They are. See this right here, this is 4 units of 90 degrees. Same as this point right here, 4 units of 90 degrees. This right here is 4 units of 90 degrees. See, the thing is, this line, and this line, and the same goes for this one here, yeah? These 3 lines At no point in time do they interact with that line, or this line. Get that out of the way. They don't interact with those lines at all. They never touch them. They never ever touch those lines. I swear it to you, okay? When you recognize that this is 4 units of 90 degrees, you'll see that what you're actually observing is a cube made of 9 squares that does not expose any of the edges of that cube. Which is probably why there's a temple in Cambodia that has reference to a cube via dodecagon. And it says that it's made using the Sri Yantra. Because it was. It was made using this. There's so much more information that can be said. And I'm going to say something that I feel is a little bit bold, a little bit brave, and I'm going to say it with confidence. The number 7,776 is apparently the number of the angels. The angels. Because see, if you take 108 and 72 and you multiply them, you get 7,776. And I know that 108 and 72 are the angles. That's a bit confusing. 7,776 is an extremely relevant number because it is the number of the angles. The angles. Okay, the angles. There's so much more information. And I wish I could give it all to you just by picking a small piece of my brain and then holding it in front of the camera and offering it to you like that. But unfortunately, I'll have to explain some more stuff in another video. Thanks for watching. I'll see you again soon. Or maybe you'll see me, or something like that.